If you ever look up what the word compound means, you think as in a compound sentence. It basically means two things that are put together and made into one thing. So just like a compound sentence, for example, would be Joseph went to the park and he went to the mall. That's really two sentences that's combined into one. So when we say compound inequalities, it's really two inequalities, which are basically math symbols such as less than, greater than, less than, equal, greater or equal to. Basically, we're going to do problems that have two of these signs, but it's going to be two of these signs put into one problem. So we have two different types of compound inequalities. We have and statements, and we have or statements. And the difference is an and statement means both pieces of information are true. For example, a number can be smaller than 8 and bigger than 3, such as the number 5. 5 is more than 3 but less than 8, so that works. The difference is with an or statement, if I said give me a number that's more than 10 and less than 0, there is no such number, so I would need to say the word or. Give me a number more than 10 or less than 0. Now it's possible to answer the question. So we're going to write that a number can be greater than 2 and less than 6. So again, a number can be greater than 2 and less than 6 at the same time. And the way we show that is we use x for a number, and we say more than 2 but less than 6. So we kind of write it all in one sentence. So you can see there are two symbols. So it's a compound inequality. It's an and statement. You can also write it like this, meaning 6 is more than some number, and this number is more than 2. That's the same thing. So it's very easy to graph this. All you do is you put your smaller number on the left and your bigger number on the right. Since both of these symbols do not have underlines, both of the numbers get open circles. And then to show numbers between 2 and 6, we shade in between. And that's it. So what this means is any number between 2 and 6, not including 2 and 6 themselves, can be plugged in for x. So we could use the number 3, 4, 5, 3.5, 4.5, 5.5, all of those work as long as they're between 2 and 6. Whereas in an or statement, a number cannot be more than 5 and less than 2. You can't have a number bigger than 5 and smaller than 2. So what we do is we write or. So if I change the word and to or, all of a sudden it makes sense. So we would say a number can be greater than 5 or less than 2. That makes sense. You can't be both, but you can be one or the other. So we use symbols to show x is greater than 5 or x is less than 2. So the or compound inequalities will always use the word or in them because they can't both be true. So we're going to write but not both. You can be more than 5 or smaller than 2, but you can't be both at the same time. And again, we'll always use the word or. Graphing these is very easy. It's like graphing two separate problems on the same number line. So we're going to graph x is greater than 5. So just put a 5 on your number line. We use an open circle. It's going to point to the right. Now we have to graph x is less than 2. So we put 2 on our number line, open circle, and it goes to the left. So we have some and or statements. We're going to write them as compound inequalities. So since this says and, we're going to put P in the middle with two symbols that point to the left. Smaller number on the left, bigger number on the right. The only thing we need to check is the words more than and less than, and we got to make sure that neither of these is inclusive, meaning there's no underline and there will not be an underline. The 3 and 9 are not included. Right, number 2 says the word or, so we're going to have or in our answer. So to show x is at least 5, you write x is greater or equal to 5, or x is less than 2. And you leave that as your answer. So you can see the difference between and statements versus or statements. There's no words in an and. There's the word or and an or. Number 3 says and, so it's going to look like number 1. You put a P in the middle and point your symbols to the left. And the smaller number goes on the left. Bigger number goes on the right. The only difference is the word minimum and the word maximum are inclusive, meaning they both get underlines. So -3 and 2 could be used as a solution. So we're going to copy our answers here. And we're going to graph our answers just like we did before. Open circles because there's no underline, and we shade in between. We're going to graph these one at a time because of the word or. Close circle at 5 because of this underline. Going to the right. 2 will get an open circle, there's no underline, and we'll go to the left. And go ahead and graph the third one. Close circles for each number. And shade in the middle. So if you notice, the or statements will always be separated and pointing away from each other. The and statements will always have 2 endpoints and be shaded in the middle. That will always happen. So we're actually going to move on and we're going to talk about how to do the math with these problems. We'll start with the left one. We're going to show a trick to help you solve this inequality. So what we don't like is in the middle, it's not just x. It says 2x plus 3. Well, we don't like that. We want x to be alone. So you need to break it up. So we're going to copy 5 is less than 2x plus 3. But we are not going to include the symbol and 9. So we stop. Now we're going to underline 2x plus 3 is less than 9. And we're going to put that into the box. So it's kind of like we're breaking it into two separate problems. And now we're going to go ahead and solve this just like we did before. So you should get x is greater than 1 and x is less than or equal to 3. So the last thing we have to do is pair them together. Put x in the middle. 1 and 3 are your endpoints. But you need to underline the symbol that goes with 3. And that's our answer. So it's going to take some practice. It's a skill you need to acquire. But it's the same process every time. You break it up and put it back together. Now the second one's going to be easier because of the word or. The problem's already broken up. You just need to make sure you put or in your answer, which I've already done for you in this case. So let's recopy each problem in the box. And then we're going to go ahead and solve this. So we have two inequalities. Go ahead and I like to do the swap flip trick with this because I don't like my letter on the right. So I'm going to write x is greater than 6 or x is less than 3. So any number more than 6 or smaller than 3 can be put into one of these, and one of these will be true. So this whole thing is your answer. Now I'm going to give you a little time here and have you try these two. One of these you have to break apart, just like we did on the left up top, and the other is already broken apart. You need to solve it separately. So you can work at your own pace. I'm going to go ahead and do the problem a while. So you should get two answers. Y is less than 2 and y is more than -2. You need to put those together. So put your symbols with y in the middle, smaller number on the left, bigger number on the right. Go ahead and graph your answer. And shade in the middle. Now we go on to number 2. So you should get 2 answers. Make sure you put the word or in between them. Either numbers are less than 2 will work, or you can pick numbers greater or equal to 5. So graph each one separately. So check your graph, make sure it looks like mine. Solid dot at 5, open dot at 2, and they should be pointing away from each other, separated in between. Now the last 2 problems, you're giving graphs, and you're just supposed to write inequalities to go with them. So right away, I know this is going to use the word or because they're pointing away from each other. And this one's going to be an and, so I can put x in the middle with 2 arrows pointing to the left. So we're going to write the inequality for the first graph. So you can use whatever letter you want. I'm going to use P. P is less than or equal to -3. Because of this solid dot, you need to put an underline. Or P is just greater than 2. Whereas in number 4, our boundaries are 0 and 3. So 0 and 3. And it looks like 0 is a solid dot, so 0 needs an underline with it. And that's it. Those are your answers.